So welcome. This is CIE Physics multiple choice questions, the most predicted questions or the most difficult questions for the upcoming multiple choice questions. So paper 2. So some difficult questions are being discussed over here. So let us start. So the first question, a ball is dropped onto a floor. Its speed just before hitting the floor is 3 meters per second. What change which change would result in the speed 6 meters per second just before hitting the ball. So what is happening is, this is a ground. Initially, the ball is being hitting the ground with the speed of 3 meters per second. Whereas next time, the ball want to hit with a speed of 6 meters per second. So in the case 1, it is 3 meters per second, and second case 6 meters per second. Which change will be there? So we are dropping from a particular height. For example, this height is going to be h. So it will be having potential energy at the top, and at the bottom it will be having only the kinetic energy, a half mv square. Potential energy at the top and kinetic energy at the bottom. So that loss of potential energy should be equal to loss of the gravitational potential energy should be equals to gain in the kinetic energy. So mgh over equals to half mv square. The potential energy at the top should be equals to the kinetic energy at the bottom. So we can see that mass and mass gets cancels. Once mass and mass gets cancels, we come to know that it is not depending on the mass. So use a ball with a double the mass, use the ball with 4 times the mass, that both are wrong. So it only depends upon the height. So what is that? We are going to do that one. If we do the cross multiplication, v square is equal to 2gh. So we know that 2 is a constant, g is a constant, so v square is proportional to h. So we want two quantities. So v1, first one, and v2, the second time, equals to h1 upon h2. So now what should be the case? So v1 is nothing but what we know is 3 meters per second. V2 is nothing but what we know, 6 meters per second. So 3 square upon 6 square should be equals to h1 upon h2. 9 upon 36 equals to h1 upon h2. So I want h2 equals to 9 upon 36 is 1 upon 4. h2 equals to 4h1. Means the second height should be 4 times the first height. So second, if at all you are throwing from the 4 times of the initial height, so the velocity will become double. So do we have that one? Drop the ball from 4 times the height of the above the floor. So option is going to be B. That's going to be the answer. Coming to the second question, the circuit diagram shows a circuit of AC supply. It is going to be an AC supply. Means it is going to going up and down, positive and negative. Now, and a diode and a resistor. Which diagram shows how the current I in the resistor varies with the time t? Now, diode, it will allow the current to flow in only in one direction, whereas if at all it is trying to flow in the other direction, it will block it. That is the purpose of diode. Only one direction is allowed. So we can see that what is this? The option A is wrong because it is in both the directions, and option C is also wrong because it is 0. So diode will allow current in one direction. Means in the second direction it will block. But over here we see that in the second direction also it is there. So this is option D is also wrong. So I am left over only with option B, which is correct option because it is allowing in one direction, whereas in another direction it is blocking, and in another direction again it is allowing. So alternatively it is allowing and blocking. So therefore option B is the correct answer. Coming to question number 3, after some building work in a house, a bare uninsulated live wire is left protruding from the wall. What is the greatest hazard? So the greatest hazard has to be, it cannot be a fire. Why it cannot be a fire? Because it's just only a wire and there is nothing, any another short circuit chances are there. So therefore it cannot cause a fire. And a fuse blows because there is a total not complete circuit is there. So therefore a fuse blowing is also not possible. No current flows, no. If through the wire, current will be compulsorily flowing it out. So only the option is left over is nothing but what? An electric shock. Yes, an electric shock can be there if at all. What is this? A live wire is being kept protruding from the wall. That's going to be the answer. Now coming to the next question, a bullet of mass 0.1 kgs travels horizontally at a speed of 600 meters per second. It strikes a stationary wooden block of mass 1.9 kgs stationary, resting on a frictionless horizontal surface. The bullet stays in the block. What is the speed? So we know that momentum before collision should be equal to momentum after collision. So total momentum before collision equals to total momentum after collision. So total momentum before collision. So bullet is mass of 0.1 and its velocity is 600. And for that of block is 1.90 kgs and its velocity is 0. Then after that, both coalesce together. Coalesce together means they combine together and they will be moving with a velocity v. So this becomes nothing but what? 60 plus 0 equals to 2v. So 2v equals to 60. So v equals to nothing but how much? 30 meters per second. That's going to be the answer, option A. Coming to the next question, different waves travel through air. Which waves have the greatest difference in the speed? So the first option is says that ultrasound waves and the sound waves. So both are nothing but what? Both are mechanical waves. Both are nothing but what? Mechanical waves. So both mechanical waves will be having the same speed. So therefore the first option is not correct. Second one is nothing but what? Ultrasound waves and ultraviolet waves. So the first one is going to be a mechanical wave, ultrasound waves is going to be a mechanical waves, whereas ultraviolet waves is nothing but electromagnetic waves. Electromagnetic waves. So both will be having it at different velocities. Electromagnetic waves will be moving with a velocity of 3 times 10 to the power of 8 meters per second. Ultraviolet waves and light waves both are again electromagnetic waves. So therefore option C is also wrong. Then ultraviolet waves and radio waves will be having the same speed. So option A is wrong, option C is wrong, option D is wrong. So only the option which is correct is nothing but what? Option B. That's going to. Coming to the next question, a pair of cutters is used to cut a rope. Where should be the rope be positioned? At which labeled point should the hands be positioned to produce a greatest cutting force? So this is going to be the pivot. Pivot is at that point. So whenever we are doing it, or whenever we are applying the force from the pivot, we know that there should be a maximum distance. The distance of the force should be nothing but what? At the maximum. So therefore, we should be placing it out to in order to get a maximum for moment which is force times distance or torque. So therefore, moment is the most important suitable word. So in order to get the best moment, what it says, it should be at a maximum possible distance. So hand should be placed at S. So when I see that hand should be placed at S, so option A is wrong and option C is wrong. So it has to be option B or D. Now what is the thing is, for example, we take this an example as, let us produce with this one a moment of 100 Newton meter. 100 example 100 Newton meter. So now if at all I'm choosing this P, maybe this distance from the pivot is going to be 10 meters. If at all I exist, then what will be the force it will be causing it out? 100 Newton meters should be equals to 10 times the force at P. So force at P is equal to nothing but what? 100 divided by 10, which is just only 10. Whereas if at all I place it at Q, Q distance is relatively nearer to pivot, right? Let it be 1 meter. So I use the same 100 Newton meters, which is produced by my hand, should be equals to force times distance. So force at Q times the distance. Distance is 1. So force at Q equals to nothing but what? 100. So you can see that 100 newtons of force is created when I'm placing the rope at Q rather than placing the rope at P with the same position of hand at S. So therefore, the rope should be placed at Q. So option D is going to be the answer. Coming to the next question, question number 7. A 150 filament bulb has an efficiency of 10%. A 40-watt compact fluorescent lamp has an efficiency of 30%. So filament lamp and composite fluorescent lamp. So this is 150 watt and efficiency is only 10%. So 10% of 150. So which is going to be nothing but how much? 15 watt. So remaining what it says, this is the output. So the energy which is wasted in the form of other forms is nothing but what? 135 watt. Whereas in case of CFL bulb, it is 40 watt. Efficiency is 30%. 30% upon 40, which is nothing but what? 12 watt output. And what is going to be the wastage? Wastage is nothing but what? Only 40 minus 12 is nothing but what? 28 watt. So we can see that from the efficiency, filament lamp is only 10% efficient, whereas compact fluorescent lamp is 30% efficient. Now, what is he asking? Which produces more light? So we can see that 15 watt and 12 watt. Which produces more light? Filament lamp produces a more light. So therefore, option has to be either C or D. So option A and B are totally wrong. Option A is wrong and option B is wrong because I'm not getting more light. I'm interested in the form of more light. More light is in the form of from the filament lamp. Now converts more energy into another form. So you can see that more energy is converted in the 135, 90% is converted into other forms, whereas over here only 70% is converted into other form. So therefore, what is going to be the option? Option D is going to be the answer. Filament lamp and filament lamp in both the case. Coming to the next question, question number 8. A battery is connected to a circuit. It's switched in for 1 minute. 1 minute means 60 seconds. Don't forget to use the time in 60 seconds. During that time, there is a current of 0.4 in the circuit and the battery supplies total energy of 48 joules. Which row gives the charge? Charge is equal to Q is equal to IT. I is how much? 0.4 and time is 60. So which is nothing but what? 24. So coulombs. So charge is going to be 24 coulombs. So option, it has to be either C or D because option A and B does not have charge 24. Now, apart from that, EMF. We want to know the EMF. EMF equals to nothing but what? VIT. So which is nothing but what? Energy. We have given 48. Voltage, we don't know. And I is IT. IT just now we have calculated as 24. So from there, voltage equals to 48 upon 24, which is going to be 2. So which option is the correct option? Option C is going to be the correct answer. That's going to be the answer. Coming to the question number 9, a dam across a lake is divided into two sections by a rock. Section X is longer than section Y, but two sections have otherwise identical. They are having the same depth every way. The diagram shows a view from above of the lake of the dam. The water creates a total force on each section of the dam and average pressure on each one. So which statement is correct? So pressure equals to nothing but what? Rho GH. So we know that they are of same height and G is a constant and the rho density is also going to be a constant. So obviously the pressure is going to be constant because pressure depends upon the formula rho GH. We are not supposed to take the formula for pressure as force upon area because it's not a solid, it's a liquid. So we are going to take it out rho GH. We can see that the height is the same because he said that same depth. G is a constant and the density is also going to be a constant. So the pressure is going to be the same. So which option is the correct option directly? The first option A is going to be the same. Coming to the next question, the speed time graph shown is for a car moving in a straight line. What is the acceleration of the car when the time is at 40 seconds? At 40 seconds, what is going to be the acceleration? So what am I going to do? I am going to draw a tangent at 40 seconds. So we can see that it is a tangent parallel to the time axis. Anything which is parallel to the x-axis is going to be, what is the slope? The slope or the gradient is going to be nothing but what? 0. So the slope is nothing but what? Slope of a speed time graph is acceleration. So acceleration is equals to 0. So which option is the correct option? Question number 10. For that, option A is the answer. That's coming to the next question. The diagram shows a part of an electric circuit. The current is in 4 ohms resistor is 3 amperes. Now the current in that one is going to be 3 amperes. Then what is the current in the ammeter? So he's asking us to find it out. What is the current in the ammeter? So over here, so we know that current equals to 3 and resistance equals to 4 ohms, 3 amperes and 4 ohms. V equals to IR Ohm's law. So 3 times 4, which is nothing but what? 12 volts. So, and now what is that? It's going to be, it's parallel. We can see that 4 ohms and 2 ohms are in parallel. So in parallel, what is that? We know that voltage is constant. Voltage is constant. So therefore, over here also it has to be nothing but what? 12 volts. So 2 times of the, what is this, amperes current should be equals to 12. So I equals to nothing but what? 6 amperes. So what is going to be the total current over there in the 2 ohms is nothing but what? 6 amperes. So now what is he asking? What is the current in the ammeter? So when I see that the current in the ammeter is going to be the total current, because 3 amperes is going from here and 6 amperes goes from here. So therefore, what will be the total current that has to be coming from the ammeter itself only? So which is nothing but what? 6 plus 3, 9 amperes. So which option is the correct option? Option C is going to be the answer. Coming to the next question, question number 12, a stone of mass m is held in water. So therefore, this is the level of water. For example, a stone of mass m is held in water. It is inside the water. A stone is released and it falls vertically a height of h. So it is falling a vertically height of h. Some of the original energy of the stone is transferred to the water. As it falls, resistive forces cause the temperature of the water and stone to increase. which expression is work done against friction. So we have to use this formula, very simple formula, total work done, TWD equal to total work done, which is delta PE plus delta KE plus work done against friction. WDF means work done against friction. So total work done is 0 because we are not pulling it or we are not pushing it. So it is falling on its own due to gravity. So therefore total work done equals to 0. Delta P, final potential energy minus initial potential energy, MGH. Final potential energy is 0 because it is reaching the ground. Initially it is at a height of h, MGH, plus delta Ke, final kinetic energy, half mv square. Initial kinetic energy is 0 because it is at rest, plus work done against friction. So now I want work done against friction, so move that all the other sides. So mgh minus half mv square. This is going to be the answer. But we can write it out over here. Final potential energy and initial potential energy. Final kinetic energy minus initial kinetic energy. So if at all you use this formula, remember work energy principle formula, total work done is equal to delta P plus delta Ke plus work done against friction. You need not worry about the symbols. The symbols will be taken care of on its own. This is the most beautiful method of doing it out, work energy principle, which you may not be able to see it out in the other videos. So total work done equals to delta Ke plus delta Pe plus work done against friction. The symbols are taken care on their own. Okay. So no need to use loss in potential energy, gain in kinetic energy, and so on. No need to worry about all this. Okay. When I say delta P, final minus initial, that's all. That's going to be the answer. Now coming to the next question, question number 13. A small compass is placed close to a star bar magnet. There's the same distance from each point. Which diagram shows the direction of the compass needle points? Which diagram shows it? So we know that always outside the, what it says, the bar magnet, the magnetic field will be in this particular direction. And inside it's going to be straight. So always from north going towards the south. So we can still draw that over here. It always goes from the north and what it says goes towards the south. So over here also it is going to be the same. Start from the north and goes towards the south. And only inside the magnet it is from south to north. Outside the magnet is going to be from north to south. Now we know that the magnet will be always, what it says, aligned with the magnetic field direction. So therefore we can see that it is not aligning, it is in the opposite direction. So therefore this is wrong. This is not aligning, not wrong, and this is not aligning, so this is wrong. So only option, which option is correct? Option C is going to be the correct answer. Question number 14. The diagram shows a uniform bridge of 4 meters long weighing 10,000 newtons. So it is a uniform bridge. So the weight will be acting from the middle, 10,000 newtons. This is 2 meters and this is going to be 2 meters. The bridge is pivoted at one end. The force at the other end gradually increases until the bridge begins to lift. So therefore we can see that anti-clockwise movement should be equals to clockwise movement. Anti-clockwise movement is nothing but what? The force times what is the distance? 4. And clockwise movement is the 10,000 newtons times what is the distance? 2. So 4F should be equals to 20,000. So F equals to 20,000 divided by 4. So which is going to be nothing but what? 5,000 newtons. So which is going to be the answer? Answer B is the answer. Coming to the next question, question number 15. Which distance time graph, not displacement time graph, represent the body whose speed is decreasing? So as such, I stressed on distance time graph. Distance time graph can be never be going to negative. So option B and D is going to be wrong option. If at all it is a displacement time graph, it can go downwards. So it is a distance time graph, so it cannot go downwards. It is always, what is this, going upwards. But what is the thing is, so therefore option B and D is wrong. But now the speed is decreasing. So therefore option A is also wrong because we have to, it is contradicting with the concept of speed is decreasing. So only option correct is option C. That's going to be the answer. So these are the top 15 questions of the part 1 for the multiple choice questions for CAIE upcoming multiple choice question paper. So remaining in part 2 will be done. So this is a series of videos. So you can keep on checking it out for the next parts. So see you in the next video. Bye.